Yeah, yeah. That's true. In general, in this, I've just written the formula down in words saying what it is. If you look in the notes or in the standard, if you look in the standard, there is an N in front of the EI over L here. And that depends on the end fixity of the member. If the member's fixed at its end, N is 4 EI over L, that's what we think normally would be the stiffness. But if you know for sure one end is pinned, that drops to 3. And the reason that happens is because a member with one end pinned is 3/4 as stiff as a member. But in this case, so from there on, that'll give you the eccentricity at the top. So we can check out the wall at the top. It's effectively the same sort of thing as we were doing in here, getting the stress in that wall, the same calculation, but now we're working on the thickness. So that's the top. Strictly speaking, at the top, another possibility is no load here, no moment here, and a higher vertical load. So theoretically one should also check that case. What else could somebody go wrong? So, okay, we've now got to check the middle fit. Let's say you've calculated an eccentricity at the top of the wall there. We've calculated it from that moment calculation. Now we want to know, that's the height of the wall there, H, what's it going to be at this level here? The middle fit. So how are we going to find the eccentricity there?
215H, is that 1/5 of that?
We've got it at the top. It sits on the foundation down there. How do we get it at that level there? Well, to do that, we're really going to have to know what happens to the hinge. And that's where you have to make a judgment. There are two options, and as far as an exam is concerned, it wouldn't matter what you took, as long as you take one of them. In practice, people might have different opinions on it. But if we assume it's fixed here, that's what we said. We assumed there anyway. But if it is fixed there, could you say what the eccentricity there would be, just from looking at it?
0.
Let's put it another way. But the same at this level here. Let's say we've got a moment up there of n. Okay. What would the moment at the bottom be? Half. If we take a member that's fixed, apply a moment of one end, the carryover to the other end is a half. That's right. So what we would get is m over 2 if that's fixed. So if we made that assumption, what would the eccentricity there be? Et over 2, that's right. So, and that would be perfectly sensible and valid. In which case the eccentricity diagram looks like that. And by similar triangles you can work out the value there, which is the thing you need to stuff in those formulae there. So that would be okay. Is there another assumption we could make? We could assume it's pinned, in which case you get 0 at the bottom. So if we, white will use fix, and red, and in that case we'd get an eccentricity diagram like that. So that would be 0 pinned. In which case the eccentricity we'd have to use would be that. If you look at it, the pin gives you the higher eccentricity. So that's the worst case. So in practice, a lot of people would just simply assume it's pinned. Unless you're really in trouble trying to justify the wall, if it works for the pin case, it must work for the other. From your point of view, I suppose, sitting in an exam, if you have to work out the distance to the red line, you can do it in your head and you'd be able to tell me now it's 3/5 of ET. If you had to do it for the white line, you probably can't quite do it in your head. You would have to think about the similar triangles. So in terms of time, in an exam, it would make more sense to pick the pin. As long as you just simply say assume pin base, that's fine. And it's the worst case, so it's sensible in terms of what people do in practice. So I think in an exam, that's what I would probably do. I mean, it's not very difficult to work that one out, but and I think that's really all there is to it. Yeah, that's the whole of that question. Does it seem long, that? No? Just since I haven't got it here, I mean, clearly, I've just gone through the principles. There'd be a good idea for you to actually just work out the details of it yourself, you know. But in terms of an answer and just the length of it, because we have to produce these model things, sometimes I get lost. But that down to there is answering the first bit. Not a lot of writing, it's mainly diagrams. And the calculation bit takes, less than half a page. So, you know, sometimes when you stand up here and talk about it and write things out, it does look sort of fairly lengthy. But just if you want to know, somebody said, what was the eccentricity I got? The eccentricity I got was 10 millimetres at the top. Yeah, 10 millimetres at the top. You need to do some yourself. We've been through it, all you now have to do is just fill bits in, isn't it? So, any questions about that one? I think with that we've really covered just about everything there is in Masonry between those two.
Is that epsilon just from the dead load from the floor?
No. In this case, it tells you that the load coming down from above.
So you don't have to worry about the...
Yeah, so the total load here will be the load from the floor, the load from above. Okay, well I think we're up to 11:30 now. That covers pretty well everything there is, I think, in Masonry. Unless anybody can think of anything else. Okay, well it's 11:30 now. So, if you like, we can stop. Or I'm okay till 12. So, if anybody wants to come and have a chat about it.
The question is that ask about the minimum design strength level.
What's on this sheet?
What's the procedure for that?
Just what we did here.
I've got the moments and the simplicity, that's all fine.
What's this?
That.
The thickness of the wall now, rather than the length.
Right, okay.
So basically,
Was this all this? He's talking about the gamma and all that. No, like gamma G and gamma gamma thing. This is not hard.
yeah.
I probably I don't know. He's not asking the example yet. So.
I'll send you an email. Yeah, no, you're very welcome.
I've got a pretty pink folder. question. No question.
I like the question. I want you to write out all the past papers and give them to him to check, and then he'll give you the correct answers back.
I'll give him composites. I mean, composite one, I've done all of that.
Give it to him, innit?
Give it to him.
No, first take pictures.
Huh?
You're taking pictures, right?
Take now.
Take pictures now.
Go on then.
You take them. You take them.
It's going to be very quick with the shells.
Phil, it's awesome.